Good day, folks. This is video number 15 on the playlist, which is devoted to 3D Experience CATIA, the generative shape design application. The icon that we're going to be looking at is the Affinity icon, which has some similarity to the scaling one that was already discussed in video 14. But it's a little bit different. So when you go to the generative shape design, and you select the transform uh, tab, uh, the affinity icon is going to be among the things that are available there. And in fact, there is a pull-up menu, which affinity is one of them. I did access to access in video 13, scaling in video 14, and now we're going to be doing affinity. When you click on the affinity icon, this dialog box opens up, and it needs to be completed. There is the same icon is also available in the part design, and in fact, the dialog box is pretty much the same. It's exactly the same, and therefore, if you know how to do it in GSD, it's the same thing in the part design. All right, let me go ahead and do it through an example. I'm going to create, I'm in generative shape design, and I will create two things. Uh, on the vertical plane, I'll sketch, okay, sketch a half an arc, half a circle, like that. And, just, yeah, so that's what it is. Exit, and I'm going to extrude this. The actual size doesn't matter, so just extrude it like that. Okay. Then what I'm going to do is uh, create a plane which is at 45 degrees to this vertical plane. And we know how to do that. So let me go ahead and go to a wireframe. Here's a plane. And the method that I'm going to do it is the different ways of doing it. But one way is, for example, let me see now, angle normal to a plane. That should do it. Okay. You select this. Rotation axis, I select Z axis. The reference plane, for example, is that vertical plane, and put down 45 degrees. So here's the tilted plane. Now on that, I will draw something similar to that. So on that, I will sketch, again, half an arc. These dimensions don't matter. Okay, I'll draw something like that. Not exactly the same thing, but right there. This is a 45-degree angle to that. And I'm going to extrude that also. Okay, good. So we have one in the YZ plane. The other one is at the 45-degree angle. Okay. So now we're going to go and do the following. Let me go to the transform and find the affinity icon. Let me see. It's under the place where you find translate, rotate, symmetry, scaling, axis to axis. Affinity is right there. All right. It says the element. What is it that you want to scale essentially? Let's start. Notice the first thing that it did, the first thing that happens when let's try again. Look at the coordinate system here. These three planes. And as soon as I click on the affinity, it puts a coordinate system XYZ here, which is aligned with the global XYZ. Okay. This is the global XYZ. So it put that the red coordinate system right at the origin and align with the XYZ. Okay, good. Now it says, what is the element? I'm going to select that surface. And it says, where is the origin? Well, just use the default origin and the default XY plane and the X-axis. Default. Now, look at what happens when I say ratio 2 in the X direction. See, what happened is that it created Let's try this thing with 3. See, it took that surface that I had there and extended it, okay, for a ratio of 3. Okay, so let me put this thing back where it was. That was 1. Let me do it in the y direction. Put down, for example, 2 here. Review. So what it did, it stretched it. It stretched every point, the coordinate of every point, by a factor of 2. So if this, hypothetically, if this coordinate was, let's say, 5, if the y coordinate was 5, the y coordinate of this new one is 10. Okay, you get the picture? All right. Now, if I put this thing back to 1, now make it z. Let's make it, for example, 2 in the z direction. This is what happened. So every z coordinate of this surface is doubled. Okay. Now, cancel. Let me show you something else. Suppose I move, I click on Affinity, and as the origin, first of all, for the element, we select that surface, no problem. For the origin, I select this point. So what it does, it takes this coordinate system and it places it right there, or right there, actually, if whatever I pick. So if I put it there, it's going to move it right there. And then I have the ability of changing my x, y, x, z, y, z plane. I don't know why I would like to do that in this example, but it is possible. For example, instead of x, y being like that, I can select x, y being like that. Maybe that's so convenient. For example, let me do that. For x, y, let me select this. Notice that this becomes x, x becomes y. All right? And even you can change the label of the axis. For example, if I select for the x-axis, right now it's going like that. If I select this edge, notice that it put the x-axis, move this thing out of the way. It put the x-axis, I don't know whether I actually did it or not, but let's try it. Yeah, this edge one. Put the x-axis along this edge one. So I'm not sure. Let me zoom in for a second. Yeah. Yeah. It made this thing the x-axis. Okay. Now, everything is one, so no problem. And let me make this thing, for example, 2, y2. So it stretches in the y direction, which is going up. Okay. Or if I do, let me put this thing back to 1. If I do, for example, for x equal to 3 or 4, it stretches in the x direction by 4. Good. Etc. Now cancel that. We cancel that. I'm going to do the exact same to that other surface there, but just bear with me for a second. Let me create a point halfway between these 2 points. So we go to wireframe, point between this point and that point. Okay, that's good. And now we go to transform, affinity. For the surface, I select, for the element, I select the surface. For the origin, I select this point. Notice that it moves this thing and put it there. And you can change your x, y, z, etc. But now look what happened. If I say, for example, stretch things in the direction in the direction x by 2, what happens? It maintains that circular shape. If I say in the y direction by 2, okay, and finally, if I say in the 3 direction by 2, it does this. Okay. All right. Now let's go ahead and do it to the, let me undo this, Control Z. All right. Let me do it with this other surface. So affinity element is that surface. It created this in the global XYZ direction. Origin, I set it, for example, let's actually make this thing uh, XY plane. I leave it the way it is. X-axis, I select this edge. See that? I select this edge. And now when I say stretch it in by a factor of 2 in the X direction, this is what happened because this is what X is. In the Y direction by 2. See that? Etc. And Z direction, same thing. Cancel that. Something else I want to do. Let me try to do that one more time. So we go to affinity. We leave this thing. I'm not going to reorient the X direction, but the surface is going to be that. Now let's put some numbers here. So for example, when I say in the X direction by a factor of 2, this is what happens. Okay? Put this thing back. In the Y direction by a factor of 2, okay? You get something that's kind of weird. You got to be careful with these things because these orientation make a big difference. Okay? And finally, let me put this thing back to 1 and this thing by 2. This one is okay. But for Y, you can see that it's really ugly. Those orientation are critical in what you're going to be getting. You can see that. It heavily distorts it. The same thing applies to solids. For example, let me go ahead and let me just go ahead and delete these things. Okay, so let me go and make it some kind of a box, for example. On that plane, I will sketch a circle, or not a rectangle, exit, and go to volume, add it, make this thing a little bit higher, something like that. All right. So now we go to affinity. We go to transform, affinity. The element is that box. So global, the default coordinate system is here. I don't want to change the origin or the orientation, just leave it the way it is right now. And that's it. So for example, if you do this thing 2, notice that what it did, it actually created another piece of things were stretched out. Go to affinity. Let me do this thing. Let me put this thing back. Well, let me do this thing also 3. Okay. So it took this and stretched it by 2 in the X direction, by 3 in the X direction, by 2 in the Y direction. And if I put, for example, Z equal to 0.5, it shrinks it in the Y direction. Yeah. Yeah, that's pretty much it. Now, if this orientation, let me do the following. Let me do the following. For example, I'm going to create a line between this point and this point. You're going to see, no, sorry, point to point. Cancel that. Try it again. A line between this point and this point. You see why I'm doing that? And then I go and do transform, affinity. This is the object. Origin, I'll leave it the way it is. And for the x-axis, I use this. Notice that it rotated that so that this line and the x-axis are aligned. Now, let's put some weird numbers there. Let me put these things back to 1 first of all. So you see where we are starting. Right there, no problem. Preview. Now, this is the old one, right? This was the old one. Just to make sure you don't get confused, let me cancel that. Let me delete this fellow. This fellow is that one, right? We're going to delete that so that it doesn't bother us. Try Affinity again. Select this. And let me put these sticks back where they are. 1, 1, 1. But for the orientation, I select that. That doesn't make a difference. Let me make this thing 2. Yeah. You see, it distorts this. The orientation of this, we got to be careful. I showed you that in the case of a sphere, it will distort it. It will, depending on how it is. And for a volume, it does. Anyway, affinity and scaling are closely related, but there are things you can do here faster that in scaling, it takes you a while, etc. And the other way around, by the way.